Okay, so first of all, let's just look at converting between kilometres um, per hour and changing something to metres per second. Because in order to get the stopping distance, we need to do that in metres. So if our speed is in kilometres per hour, then we're going to have to change from kilometres per hour to metres per second. Now, 70 kilometres in 1 hour. Okay, what that would mean is that would be 70. If you times 1,000, you get it into meters. So it's 70 meters. And I'm just going to remove this part, this one and this one. So that would be 70 meters, 70,000 meters because you times 1,000. So it's 70,000 meters in 1 hour. And then that's 1 whole hour. So that's how far you go in 1 hour. If you're going to go for 1 minute, then you would have to divide the 70,000 by 60. So if you divide the 70,000 and you divide it by 60, that would be 70,000 divided by 60, which is 1166.6 recurring. That's in 1 minute. So I'm just going to keep that in my calculator. And then I'm going to now do it for 1 second, which would be less time. That's why I'm going to divide. So if I divide by 60 again, then what I'll get is I'll get it for 1 second. So I get 19.4. So it's actually 4 recurring meters in 1 second, and that was meters. So step 1 is to change it to meters. Step 2 is to change it to minutes. Change it to minutes. And then step 3 is to change it to seconds. So you go times 1,000, that will change it to meters. Divide by 60, that'll change it to minutes. Divide by 60, that'll change it to seconds. So let's just look at this 75 kilometers per hour. So times by 1,000, that will give you 75,000 meters in 1 hour. Divide by 60 and by 60 again, that changes it to minutes. We get 75,000, divide 60, divide 60. That means that in 1 second, you will go 20.8 meters in 1 second. So you've changed it to meters per second. So the second part of this is working out what the reaction time distance is. So the reaction time is how long it takes you to react. So say you were driving your car, how long it takes you to get your foot on the sitting on the ground of the where your feet go in a car to putting it onto the brake. Okay, so this person, it takes them 1.5 seconds to actually react, say when something runs out in front of the car. So the car's traveling at 70 kilometers per hour. How far would they go in 1.5 seconds? Now see how that's in, you can't really look at that if that's in hours. And we don't want kilometers, we want it in meters because you're only going to go meters. So you need it in meters per second. So get the 70 kilometers and you times by 1,000 and that will change it to 70,000 meters. And that 70,000 meters will be in 1 hour. And then to get to 1 second, you divide by 60, that will get it for a minute. Divide by 60 again. So if we go 70,000, divide by 60, divide by 60, I end up with 19.4 recurring. So I'm just leaving that as a decimal. You could put it as a mixed fraction too if you want. It's 19 and 4 are 9s. That's like, you just want to make sure you've got it exact. So what this means is that's your speed in meters per second. So your speed is 19.4 recurring meters per second. Your time is 1.5 seconds. Now, if you think of our little triangle, and our little triangle goes speed equals distance over time. So we've got speed is distance over time. So what we actually want is the distance because we want how far you're going to travel in 1.5 seconds. So we want the distance. So the distance is the speed times the time. So it's 19.4 times 1.5. So you go times 1.5 and you end up with 29.17 meters. So that means in 1 second, you're going to go 29.17 meters. Okay, so let's just look at this next one here. All right, so the car travels at 90 kilometers per hour. The reaction time is 1.4 seconds. How far will it travel? So that's called the stopping distance. So how far you go in the time it takes you to react to putting your foot on the brake. Okay, so step one, you got to get the 90 kilometers per hour and you have to change it to, so it's 90 kilometers in 1 hour. You have to change it to meters first because you're going to travel in meters. It's a very short distance. That's why it's going to be meters, not kilometers. Step two, let's get rid of that again. So step two, you need to get it to minutes and seconds. So if you divide by 60, that will give you 1 minute. And then if you divide by 60 again, that will give you 1 second. So this will get your speed in, we're just going to do it in the calculator. So you've got 90,000 divided by 60 divided by 60. So that means you go 25 meters in 1 second. So that's your speed, 25 meters per second. That's the speed. Your time is 1.4 seconds. So to get the actual distance, use your triangle. Speed is distance over time. Cover up the distance, so it's speed times time. So it's 25 times 1.4, which is 35 meters. Okay. All right, so the steps in this, change the 90 kilometers per hour to meters per second. You do that by times in by 1,000, divide by 60 and 60 to get it for 1 second. Times in by 1,000 changes it to meters. The 60 and 60 changes it to seconds. Next step is you want to get the stopping distance. So to get the distance, you now have the speed in meters per second and the time in seconds. So it's just speed times time for distance. All right. So braking distance. So you will be given a formula for the braking distance. So you've just got to basically put it into the formula. Now, the V is the speed in kilometers per hour. The D is the braking distance. So you've got 0.01 times 70 squared, because it's just a matter of substituting the 70. So the 70 is the V. The formula is D is 0.1 V squared. So where the V is, you just have to put in the time sign and replace it with the speed. So you just go 0.01 times 70 squared and you end up with 49 meters. So that means that when you put the brake on, you're still going to travel about 49 meters if you're traveling at that speed. Okay, so once again, use the formula. This is when you put your foot on the actual brake, how far will your car go? Like, will it slide? So it's if you're going at that speed. So if you're going at 65 kilometers per hour, it's 0.01 times 65 squared. So you'll go 42.25 meters. So the braking distance is in meters and V is in kilometers per hour. So it's a good way to convert it. So the braking distance is 0.01 V squared. So once again, this is in meters, this is in kilometers per hour. So you go 0.1 times, the V is 80, so it's 80 squared. 0.1 times 80 squared equals 64 meters you would travel if you're going at 80 kilometers per hour and you suddenly put your foot on the brake. Okay, so the total stopping distance in your car is made up of two things. It's made up of when you put your foot on the brake, how long it takes you to actually put your foot on the brake. That is called your reaction time distance. And that's where you do speed in meters per second, and then you do the time you've already got. So it's speed times time. That's using this formula for D. You want the distance. So first you've got to change the speed. First of all, you change the speed to, you change the speed to meters, and then you divide by 60, so you times 1,000, divide by 60 to get it in meters per second, and then you just times by your reaction time. How long it takes you to react to put your foot on the brake. Okay, and then to get the braking distance, you just put the speed and you just sub it in for V, and you'll have the stopping distance and you'll like the braking distance, so you'll have that in meters. You then just have to add these two things together. If you add them together, you get the total stopping distance. So let's just look at Jack. So Jack, first of all, here's a driving speed of that and decides to brake. His reaction time's 1.8. There's his braking distance. Okay, so let's go for it. All right, so first of all, we need to get the stopping distance. So the stopping distance is that we have to do the reaction time distance first. That's step one. Then we have to do the braking distance. And then we do the total stopping distance. Okay, so the reaction time, just going to add another page in here. So to get the reaction time, we need to get the 80 kilometers per hour, and we need to change it to meters. So that's meters in 1 hour. Then to get it per second, because we need to get the same units, we divide by 60, divide by 60. Keep that in your calculator so that you don't use a rounded off. I get 22.2 recurring. And then that's how many meters per second. So then you use your speed is distance over time. So we're trying to get the distance. So we do speed times time. The reaction time in this question, if we go back up to the question, was 1.8 seconds. So it's 22.2 times 1.8. Keep it in your calculator, times 1.8, which is your travel, 40 meters. Okay. In the time that it takes you to react. Okay, so then you've got the braking distance. This is if you're going at this speed. We need to use the formula, 0.01 v squared. Replace the v with the speed. So 0.01 times, now the speed was 80. That's 80 squared. 0.01 times 80 squared equals 64. So you just go 64 plus your 40 meters. So I'm just going to make sure that I'm not using my rounded off. 8,000 divided by 60 divided by 60 times 1.8. Yep, I get 40 plus 64. And I end up, you'll actually, if you're going at that speed and you suddenly put your foot on the brake, it'll actually be 104 meters that you'll travel. So 40 meters comes from just getting your reaction time, and the 64 meters comes from using the formula. That is your braking distance. And when you add them together, time to react and the time the car actually slides after you put your foot on the brake at that speed will be, you'll travel actually 104 meters.